Welcome to Mrs. Thomas's Common Core Math videos. This is lesson 6, solving algebraic equations using tiles. We're going to just try one-step addition in this video, and then we'll get more complicated later. Hopefully you've watched lessons 1 through 5, where I talked about just doing operators, adding, subtracting, multiplying, and dividing using algebra tiles. And if you have, then you already have a set of ones. Red on one side, yellow on the other side, represents the value of +1 or -1. Now that we're solving algebraic equations, we need variables, and to do that, we need tiles that represent the value of x. X's are unknown. So this looks like, some people think these are tens, because you may have used 1 and 10 blocks. These are not tens. If you add them up, you can see that this isn't equal to 10. What we want to think of this as is an abstract idea. Maybe this is a container that holds ones, and it's like Hermione's small beaded bag. It can hold an infinite amount of ones. So this is representing an unknown. If I put it this way, it represents 1 positive x. And if I put it this way, it represents 1 negative x. At the bottom of your screen, there's a link, and you can print out a whole page of just positive and negative x's, like that. If you skipped videos 1 through 5, there's also a link where you can print out a mixture. So it's half 1 tiles, positive and negative, half x tiles, and you can go straight to that. In videos 1 through 5, we were just simplifying expressions. We had numbers that were being added, subtracted, multiplied, or divided, and we just tried to figure out what is that. Simplify it down to one number. This is very different. Now we have an equation. So an equation, we have an expression on one side and we have an expression on the other side, and they're equal to each other. It basically means that whatever this is, it's exactly the same thing as 4. Equals means exactly the same. This you could probably do in your head without the use of algebra tiles, but please don't. I get a lot of students who are so happy that they can just guess what x is. That's not the point. We don't want to guess. We want to have a system so that no matter how difficult I make this math, you always know how to do it, and you don't have to fall back on your guess and check. So in order to represent x plus 3, I need 1 positive x, and I'm going to use my rectangles every time I see a positive x. And I've got 3 positive ones, so I'm going to need 3 yellow tiles to represent my 3 positive ones. And on this side, I have 4 positive ones. 1, 2, 3, 4. Okay. This line that goes down the middle of my whiteboard is like a concrete wall. No tiles can pass through that. You may never, ever, ever combine tiles across this line. The rules of this is that we're trying to get 1x all by itself on one side of the equal sign. If this x was all by itself, whatever number was on the other side would be what x equals. So can you see I need to get rid of these 3 positive ones? I'm always going to want to get 1x by itself. We call that isolating the variable. Right? When you're isolated, you're by yourself. We're trying to isolate the variable and get it all by itself on this side of the equal sign, on this side of the wall. How do we get rid of 3 positive ones? Well, if you saw video 1, you know that if you want to eliminate 3 positive ones, you just need 3 negative ones to come in and eliminate them. Each negative and positive together make a 0. So by bringing in 1 negative one for each positive one, I get 0. And I'm going to show it like that. I should actually probably put these over here. Okay, so I have 3 negative ones that I added to this side. But now this equal sign isn't equal anymore. Remember, x plus 3 equals 4. Negative 3 plus x plus 3 does not equal 4. But I can balance it out. I can balance it out by doing exactly the same thing to the other side. And this is something you have to remember. that whatever you do to one side of the equal sign, you do exactly the same to the other side. That maintains this equal. You can think of it as like scales. If I take 3 away from this side, my scale's going to tip. I'm not going to have a nice even keel anymore. So I'm going to do exactly the same thing to this side, and then the scales will stay balanced. All right, so I have added a -3 to both sides, and the reason I did it was to get this x by itself. So what I'm going to do next is combine like terms. You're going to hear that a lot in algebra class. Combine like terms just means put the same stuff together. Would I combine this -3 plus this x? No, look it, they're not even remotely the same. This -3 is like this +3. They're both ones. When I'm combining like terms, I'm just gathering the ones up. And you can see that these ones eliminate, the negative ones eliminate the positive ones, and on this side, I'm left with an x. When I combine like terms, I'm left with 1x on this side. On this side, each of these 3 negative ones take away 1 of the positive ones, but since I had more positive ones to start with, I'm left with 1 positive one. I've isolated my variable, x is all by itself, and so whatever's on the other side of my equal sign is what x is equal to. X is equal to 1. -3 equals x plus 4. The first thing that I want to do, and I highly recommend that you do it, at least until you get really good at this, is draw that line through the equal sign. So I know what's on what side. Remember, that is a brick wall. You may never move anything or combine anything across that. So on one side I have -3. On the other side I have x plus 4. What am I trying to do? I'm trying to isolate the variable, get x by itself. So let's put it up in Algebra Tiles and see what I got. I got 3 negative ones on this side, right? -3 is 3 negative ones. I've got 1 positive x right here, and I've got 4 positive ones with it on the same side. So here I have 1 positive x plus 4 positive ones, and over here I know it's equal to 3 negative ones, and my goal is to get this x by itself. Does everybody see for x to be by itself, I need to get rid of the 4 positive ones? Okay, well, I know how to get rid of 4 positive ones. I just need the opposite. 4 negative ones combined with these 4 positive ones are going to eliminate all these positive ones, and I'll have nothing left. And if I add 4 negative ones to this side, I'm going to add 4 negative ones to this side. If it helps you, circle what you did. Okay, this was the original equation. I added -4 to both sides. When you circle it, it's easier to see that I did exactly the same thing. A really common mistake that students make is adding -4 to one side and +4 to the other. That's a disaster. It's a disaster. Don't do that. -4 to one side, you're going to do exactly the same thing. And if you circle what you added, then you can check before you move on. Is it exactly the same? Yes. Excellent. All right, so I'm going to bring in my 4 negative ones on this side, and I'm going to bring in my 4 negative ones on this side. Doop. Doop. All right. Exactly the same thing to both sides. I know that for each one of these positive ones and each one of these negative ones, I'm going to get a 0. I have 1, I owe 1, 0. I have 1, I lost 1, 0. Since I had exactly the same number of positive ones as negative ones, all my ones are gone and I'm left with just x on this side, which is what we wanted. Remember? Isolate the variable. Just x on this side and you are done with your solving. What I do need to do, though, is figure out, okay, I got x by itself. What do I have on this side? And for that, I'm just combining like terms. And in this case, it's all ones. And they are all negative. I've got 1, 2, 3, 4, 5, 6, 7 negative ones. -4 plus -3 is -7. So x must be equal to -7. That is my answer. All right, here's one for you to try. -1 plus x equals -3. Pause the video, do it yourself. Please use your tiles, and then restart the video and see if we did it the same way. All right, does your board look like mine? You can see I added 1 to both sides. I added 1 to both sides because I'm trying to get this x by itself, and it's over here being combined with a -1. To eliminate a -1, I need the opposite. I need a +1. And I circled so I could clearly see I added 1 to this side and I added 1 to this side. I did exactly the same thing to both sides. Then I combine like terms. These add up to nothing, and I get x all by itself on this side. And over here, this +1 is going to eliminate one of these -1s, and I get -2. X equals -2. How'd you do? All right, here's another one. 2 equals -5 plus x. Give it a try. This is what I did. What did you do? Does your math look like this? Did you draw a line through your equal sign so you can keep both sides of your equation very, very separate? I found my x. It's right here. I can see it's combined with 5 -1s, so I added 5 +1s. And I made sure to add 5 +1s to the other side to keep my equation balanced. If I combine like terms on this side, the ones with the ones, I can see that those 2 +1s eliminate those. These 3 +1s eliminate these 3 -1s, and I am left with an x on this side. Over here, I'm going to combine my like terms, but since they're all positive, I'm going to end up with 7 +1s. So, x equals 7. Would it make you happier if I wrote it like this? X equals 7. These two mean exactly the same thing. 7 equals x, x equals 7. Same thing. We just need that x all by itself on one side of the equal sign. All right, this one has a little twist to it, but if you use your skills, I think you'll be fine. Give this one a try. All right, hopefully you modeled it first. This one's a little weird because I've got 3 terms over here, a 2, an x, and a -3. Terms are just things that are being combined. Before you add anything to both sides, you want to simplify this side first. Can you see that 2 of these terms are like terms? So I am going to combine my like terms, and hopefully you can see that when I add 2 plus -3, I'm going to get -1 left. So I'm going to rewrite this as x plus -1. Maybe I'll put it like that. Does everybody see that I just combined these 2 ones with these 3 -1s? And this side doesn't change. There was nothing to combine over here, so it stays the same. So I have x plus -1 equals -1. Again, trying to get the x by itself, which means this 1 has to go. So hopefully you added a +1 to both sides. Let's circle that. So I did exactly the same thing to both sides. When I combine my like terms here, I get the x by itself, just like I wanted. But what happens over here? This -1 added to this +1 means I lose everything over there, which is totally fine. If I have no tiles over here, then x equals 0, which is a perfectly satisfactory answer. Thank you for watching Lesson 6. If you're interested in solving one-step equations that have subtraction in them, please check out Lesson 7. But before you do, make sure you've watched Lesson 2 so you can see the special way we're going to treat subtraction in the next video. Thank you for watching.